Welcome everybody. We are now into week 2 of our distant learning. I hope everyone is doing well, staying safe, keeping yourself away from boredom the best way that you possibly can. What we're going to do this week, since we have a new topic, we're going to review something that we've learned prior just to prepare us to move into what we're going to learn new for this week. And so I'm going to quickly review factoring by grouping. We learned this before we left for spring break. We'll look at a few examples. A few examples will be a part of the work that you have to do for this week. And then we'll move on to a second video, which will outlay what we're learning new for this week. Okay, so when I want to factor by grouping, one of the key elements is that I must have 4 terms within my polynomial in order to do this. And so the example that we'll start off with is one that we've probably done in class, more than likely we did. But we have 4QR plus 8R plus 3Q plus 6. And if you'll notice, I put them in 2 separate colors. So the first 2 terms I'm going to group together, and the second 2 terms I'm going to group together. So let me write that out. So I'm going to place parentheses around 4QR plus 8R, and then I have plus 3Q plus 6. Now I have 2 binomials now, and what I'm going to do is pull out the greatest common factor out of both of those binomials. So out of 4QR plus 8R, I know that they both have in common a 4 can come out of both terms and an R can come out of both terms. So when I pull out a 4R, or when I factor out a 4R, I'm left with Q plus 2. And from 3Q plus 6, I know that I can pull out a 3. And so inside of this binomial, I'm left with Q plus 2. Now, hopefully you've noticed here that both sets of parentheses have the same terms on the inside. They both have Q plus 2. So now we can consider that both sets of binomials now have a greatest common factor of Q plus 2. So what we're going to do is I'm going to take, let's use a different color. I'm going to take the 4R and the 3 and combine them together. So I have 4R plus 3 times the common factor of both of those, which is Q plus 2. And so this is the result of factoring the polynomial above. Okay, so I'm going to give you one problem for you to work on your own. So if you look on the right side of the screen, I have the polynomial 3np plus 15p minus 4n minus 20. So I want you to go ahead and factor that out. Pause the screen, factor it out, and then when you return, we'll have the answer. Okay, so now after working the problem out, hopefully, you ended up with the results 3p minus 4 times the sum of n plus 5. If so, good job. If not, just quickly go through, make sure that you pulled out the right common factors. It could be something as small as that that needs to be corrected. All right, so the next portion that we're going to look at is what if we are to factor by grouping, but we also have to utilize the additive inverse property as well. And so for this one, we have 2mk minus 12m plus 42 minus 7k. All right, and so we're having to work with this one. So to begin, I'm going to go ahead and group the first terms together, and then I'll group, see, different color, red. I'll group the second 2 terms together, and from here, the greatest common factor out of the first set of terms are, I can pull out a 2 and an m. And so inside I'm left with a k minus 6. And in the second binomial, I can pull out a 7. And what I'm left with is 6 minus k. Now, hopefully from the last two, you'll notice that what we are wanting is for whatever's inside of the parentheses to be the exact same thing. And here we have the same sort of digit and variable, but for the first binomial, the 6 is negative, and for the second binomial, let's see, can't showcase it. The k is negative, and so they aren't the exact same inside of the parentheses. And so we have to do something in order to make sure that both of the terms inside of the parentheses are the exact same for both the front binomial and the second and the back binomial. So what I'm going to do is here, see if I can show the case that here, I'm going to multiply by -1. And so when I multiply, or if I factor out a -1, what that ends up doing is changing the sign of whatever's on the inside of the parentheses. So for the front, it stays the same. I have 2m times k minus 6. And for the back, I now have 7 times -1. And since I've pulled out a -1 now, this changes everything inside of the parentheses. So now I have a -6 plus k. Now, in a bit of a different order, but if you'll notice, I have a positive k and a -6 here, positive k, -6 here. So now all I have to do is rearrange things and it will work out perfectly. So what I end up with is 2m times k minus 6 in the front, minus 7 times k minus 6. And so now we're back to what we had originally. We have the exact same thing inside of the parentheses, so we can consider them a common factor. And so my end result ends up being 2m minus 7 times k minus 6. There we go. All right. So this is our end result. Okay, so I have one problem for you to work out on your own. So I have 3p minus 2p squared minus 18p plus 27. So once you've written this down, go ahead and pause the screen, try it on your own, and then we'll come back and see if our answers match. All right, so the end result that we have for the try on your own problem is the sum of p plus 9 times the difference of 3 minus 2p. All right, so that wraps up this section. Didn't want it to be too long. It's just sort of a review over something that we will be utilizing as we move into our new information for this week. Have a good one.